This is a video for AQA Further Pure Mathematics, Calculus section 5.2, where we're looking at further integration using arctan x. I want to look at this integral, which is 5 over 5 plus 2x squared plus 2x. Now this is not quite the same as our standard integral, which has got a squared plus x squared on the bottom line, and that gives us 1 over a arctan x over a. But with some work we can change this expression here to look like this and therefore apply this standard integral. The method we're going to use is very similar to one you may have looked at for arcsine. So I need to factor out the 5 from the numerator and the 2 from the coefficient of x squared. So this becomes then 5 over 2 outside the integral, and then we have 1 over, we have then 5 over 2 plus x squared plus x dx. And then this part of the expression I can complete the square on. So we get 5 over 2 integral 1 over 5 over 2 and then plus, and in a bracket, x plus 1/2 all squared, and then minus a half squared, which is a quarter. Now if we take that quarter and subtract it from 5 over 2, 5 over 2 is 10 quarters, so taking away 1 gives us 9 over 4. So 5 over 2, the integral 1 over, then 9 over 4, plus x plus 1/2 all squared. So now this looks very much like the denominator that we want, which is a squared minus something squared. It's going to be u squared. So we're going to have a substitution to make for x plus 1/2, and a will be equal to 3 over 2. So let's now just go through that method once again. We'd factored out the 5 and the 2 from the x squared coefficient, completed the square on this part of the expression, and then rearranged to give us our expression a squared plus u squared, which is going to be when we make the substitution. So let's do that now then. So if we make the substitution, if we let x plus 1/2 be equal to u, and then du by dx is equal to 1. So making that substitution gives us 5 over 2 integral 1 over, and then we've got 9 over 4 plus u squared du. But we can then use the standard integral, 5 over 2 from outside the integral, and then the standard expression that we get is 1 over a. Remember, a here is equal to 3 over 2, so 1 over a is 2 over 3, arctan, and then u over a, so 2u over 3, and of course that will be plus c. Substituting back into that, this gives us our solution. We've got 5 over 2 multiplied by 2 over 3 arctan, and then instead of u we can write in x plus 1/2, so we get 2 over 3 and then brackets x plus 1/2 plus c. We can simplify that a little bit. The 2's obviously cancel in the first part there, so we get 5 over 3 arctan, and then considering this expression in the bracket, we can write that with a factor of 3 multiplying through 2x plus 1 over 3. So 2x plus 1 divided by 3 plus c. And that's our final result. So just recapping then, having transformed the expression that we started with by doing some work, taking out the factors of 5 and 2 from the original expression, we could then use the substitution u is equal to x plus a half. It's possible, of course, because this is a straightforward substitution, again, to see that the result is going to be just our expression with x plus a half in here. So we could jump straight from there to there by simply substituting x plus a half instead of x in the standard result. So this is x plus a half over a arctan inside there. In general then, the method well, exactly the same, to be honest, as with arcsine. We factor out the coefficients from the x squared term and from the numerator, complete the square, and then apply a standard integral, either arctan in this case, or in previous you've seen using arcsine, depending on the expression that we get once we've completed the square. That completes this video on integration using arctan, and then we're going to look at some further integration techniques using substitutions.